How does kinetic energy relate to mechanical energy conservation? Imagine watching a ball roll down a hill. As it speeds up, it gains energy, but where does that energy come from? It's all about how energy moves and changes form. Kinetic energy is one of the two main parts of mechanical energy, which also includes potential energy. Mechanical energy is the total energy an object has because of its motion and position. When an object moves, it has kinetic energy. When it's held at a height, it has potential energy. The principle of conservation of mechanical energy says that if no outside forces like friction or air resistance act on the system, the total amount of mechanical energy stays the same. This means that as an object moves, its energy shifts between kinetic and potential forms, but the total remains constant. For example, when a roller coaster climbs up a hill, it loses some kinetic energy but gains potential energy. When it zooms down, the potential energy turns back into kinetic energy, making it go faster. The sum of both energies stays the same throughout the ride, assuming no energy is lost to heat or friction. Kinetic energy specifically relates to how fast an object is moving. The faster it moves, the more kinetic energy it has. When potential energy decreases, kinetic energy increases, and vice versa. This back-and-forth energy exchange is what keeps the system balanced. This idea helps explain everyday things like pendulums swinging or cars braking. When a pendulum swings down, potential energy turns into kinetic energy, making it move faster. When it swings back up, kinetic energy becomes potential energy again. In real life, some energy is always lost as heat because of friction. That's why a moving object eventually slows down. But in an ideal system without friction, the total mechanical energy is always conserved, just changing from between kinetic and potential energy. Understanding how kinetic energy fits into the bigger picture of energy conservation helps us see how energy flows through systems. It shows us that energy isn't lost but simply changes from one form to another, which is a key idea in physics and thermodynamics.